All right, so this is day one of our Unit 4 topics on vectors. Sorry I can't be in class. I have a sick kid. So first, let's define what a vector is. A vector is a segment or a ray that has both direction and length. But instead of length, we use the word magnitude, and you see that here on page 2. So a vector describes the change in location, which involves two components. A quantity which has both force, magnitude, and direction. So the length and the direction that that ray is going, or the segment is pointed in, matter. When we talk about vectors, they usually have names like little v or little u, so like vector v, and we could put a symbol on top, or vector u. The length or the magnitude we symbolize with absolute value bars, because the definition of absolute value is length between 2 points, or distance between 2 points. So these vertical bars mean length and magnitude. The direction of a vector is the angle, so we'll use theta and our other Greek letters that we've used for angles. When you graph a vector, we have a starting point, which is called the initial point, and a terminal point, which is the end, but you have to put an arrow because you're not typically going to write these words, initial and terminal. So when you see a ray like this, you know that the arrow is pointing at the terminal point or at the stopping point, and the dot is the initial point. When you graph vectors, there are two ways to add and subtract vectors together graphically, and that's called either tail to head or parallelogram. So the terminal is called the tail, and the initial is called the head. And we'll get into this graphical way of adding and subtracting vectors tomorrow. That's our whole lesson tomorrow. Okay, so represent each of the following graphically, meaning draw the ray. We'll also find the magnitude, length, and direction, which is the degrees from 0. So with your calculators, the first thing we need to make sure is that we're in degree mode. So when you have directions like northwest and east, I draw a little coordinate plane. We've got north, south, east, and west. So north, it runs in a northwest direction. So it starts at the origin and runs northwest, and is 12 miles per, and the current or the speed of the water is 12 miles per hour. So that means the magnitude with these bars is 12. The length of that vector is 12. For the direction, anytime you have northwest, southeast, like any of those in between directions, they bisect the quadrant. So 90 degrees becomes 45 degrees on each side. And what we do is, because it's degrees from 0, let me get another color, we're going to find this angle of rotation. So we've got 90 plus 45, so 135 degrees is the direction of that vector. For B, the wind is blowing toward the east, so toward the east at 30 miles per hour. So here's my initial point, here's the terminal point. If it's 30 miles per hour, the length is 30. And because it's towards the east, that's at 0 degrees. There's no angle to that. A boat leaves from the northwest direction. So from the northwest means it's going towards the southeast, this way. 50 knots is a nautical unit of speed. So that's like if it was on land, it would be 50 miles per hour, but because it's on the water, because it's a boat, we say knots. So the magnitude is 50. Our angle, because it's directly in between a quadrant, is we have these 45 degrees. So the angle of rotation is going to be 360 minus 45, which is 315 degrees. Give the magnitude and direction for each vector. So when you have coordinates, we can do some quick calculations to find the magnitude and direction. So negative 3, 5 is negative 3, 5 is over here. And to find the magnitude, A and B is like your X and Y. Okay, so the magnitude is the square root of negative 3 squared plus 5 squared. And notice for the negative, I put the parentheses because when you type that in your calculator, you need parentheses around the negative. If you don't put the parentheses, it thinks you're doing 3 squared times a negative coefficient, which is not what you want. You want negative 3 times itself. So negative 3 squared plus 5 squared is 34. So the magnitude is the square root of 34. To find the direction, we are going to use tangent because if you think of this triangle, we've got opposite over adjacent, and I can find that reference angle in here. So the reference angle is going to be tangent inverse of 5/3. And notice these are absolute value of y and x. You don't have to put the negative in your tangent calculation because it's giving you the reference angle. You then have to stop and think, okay, so we get 59 degrees. The angle of rotation is this angle. That's the direction. So my theta, or my direction, is, in this case, 180 minus 59 because of the location of the vector. And that's 121 degrees. Now I took up all my space for B, so I'll do it up here. Over 0 and up 3. So if you want to calculate the magnitude, that's the square root of 0 squared plus 3 squared, which is just 3. And then the direction, well, if you do tangent inverse of 3 over 0, it's undefined. You can't divide by 0. So you have to look at your little picture and say, okay, this angle of rotation is 90 degrees. All right, last but not least, we've got 2, negative 4. So the magnitude is the square root of 2 squared plus negative 4 squared. Don't forget your parentheses. Oops, sorry, that's a bad glare. So that's the square root of 20. And we're going to ask that you leave the magnitudes exact. You don't have to calculate the square root of 20. The reference angle is going to be tangent inverse of 4 over 2. go? And that is, we'll round that to 63 degrees. So that 63 degrees is here, always towards the x-axis. So your angle of rotation, or the direction, for this vector is 360 minus 63 degrees, and that's 297 degrees. Okay. On page 3, a vector is something that has two and only two defining characteristics. So this is a little summary again. The magnitude is the size or the quantity, that's the length. The direction, the meaning of direction is quite self-explanatory. That's kind of funny. It means the vector is directed from one place to another. It's the angle. It's theta. Okay, so what is the direction of the vector pictured above? It doesn't really give us much context, so let's put it on a coordinate grid. I always put the initial point at the origin. So I would say that direction is going northeast. Now, this problem 2, this is a better problem. The magnitude and direction. So the magnitude of the vector and the direction of the vector. Magnitude is the length. They tell you it's 2.3. And the direction is 55 degrees. Okay, we're gonna pause the video. You try 3 and 4. We'll pause it and then we will go over it together. Okay, so for number 3, you should have said that the magnitude is 2 and your direction is 180 minus 47, which is 133 degrees. It's 180 minus 47 because this is over here in quadrant 2. If you drew the whole thing, this angle of rotation. And lastly, for 4, the magnitude is 3. It tells you a length of 3. And the direction is 3. Oh no, I don't like how they put that 43 there. So that means the reference angle is 47 to the x-axis. So I'm going to do 360 minus 47, and that gives me 313 degrees. You technically could have done 270 plus 43, but that is not a habit I like to promote. I will never ever use the 90 or the 270 unless I absolutely have to. The reference angle should always be with the x-axis. All right, go to page 4. And now we have components of a vector. Oops, sorry, you can't see that, components. So component form is when, if you're given 2 ordered pairs, you can subtract the end minus the beginning, or the terminal minus the initial, oops, to get the vector starting at the origin, which we really like because the origin is 0, 0. It's the nice starting point. And then once you get component form, you can use that to get your direction using sine and cosine of your vector. So here's how it works. Let's find the component form of ij. And I'm going to call it vector W. So vector W in component form, so we use pointy brackets to show component form. We're going to take 6 minus 3 and 4 minus 2. And now the order matters of your initial and your terminal points. It says the initial point and the terminal point are given. And I'll explain why order matters in 1 second after I subtract. So the component form of W is 3, 2. That is a complete coincidence that it matches I. So what it's saying is, if vectors have the same magnitude and direction, they're equal. So this vector that goes from 3, 2 to 6, 4 has the same magnitude and the same direction as the vector that starts at 0, 0 and ends at 3, 2. So if you imagine, if we take this vector and translate it or slide it, they're the same equal vector. Okay, so we found component form. So now the magnitude is the square root of 3 squared plus 2 squared. So it's the same process with that magnitude, which is the square root of 13. Now, because I have the component form, I don't have to use the sine cosine yet. I can go back to my original tangent inverse, and because this is quadrant 1, the direction will be the actual output of the tangent inverse, y over x. Oop, make sure you type that right. And that's 56 degrees. Oh, no it's not. Look, sorry, tangent inverse of 2 over 3. It's 34 degrees. Okay, so let's try B. In component form, we have to do terminal point minus initial point, or the end minus the beginning. So that's 4 minus 0, negative 1 minus 3. So that is 4, negative 4. Which puts my vector in the 4th quadrant. So the direction is not going to be my tangent output. Ooh, tangent inverse of 1. We know that's 45 degrees. That's on the unit circle. So the 45 degrees is here, so your direction is 360 minus 45, which is 315. Okay, the terminal point of a vector has the coordinates negative 5, 8. This way. Find the direction and magnitude. Okay, so this is another repeat problem. Here we go. The magnitude, I'm going to call it W again, is the square root of negative 5 squared plus 8 squared. You can do that in your calculator. You can do that by hand, 25 plus 64, and we get the square root of 89. Now the direction, if I find my reference angle, is 58 degrees. That's here, so the direction is 180 minus 58 for an angle of 122 degrees. Okay, find the components of the vector. Southwest with magnitude of 7. Okay, so I don't have points. That's a problem. I can't do terminal minus initial, end minus beginning. So we're going to use this setup for the component form. So the vector is going to be the magnitude times cosine theta, the magnitude sine theta. So I just copied that down here. I don't know if that's on your formula sheet. So here's the vectors part of your formula sheet. We've got the magnitude and the direction information. place in the appropriate quadrant because of the reference angle, but there is nothing here about this magnitude equation. So this is one that you have to memorize, and it's alphabetical order, cosine and then sine, just like x then y. It's a way to memorize it. Okay, so the magnitude is 7, and southwest direction is this way, directly between south and west. So this angle is 180 plus 45 for the theta, which is 225. So the vector is going to be 7 cosine 225, 7 sine 225. And we can get that as coordinates. We're going to type it in. Just make sure there's no less glare. So 7 cosine 225, 7 sine 225. And now, does it make sense that they're both negative, negative, negative? It does, so that matches my picture. That's good. So let's go negative 4.95, negative 4.95. All right, then for B, north 20 degrees east. So what that means is that's not giving you the angle of rotation. We have to draw a picture. And this is saying go 20 degrees from the north towards the east. So 20 degrees from the north towards the east. So that leaves 70 degrees here. So theta is 70 degrees. So this vector's component form is going to either be the magnitude of 12 cosine 70, 12 sine 70. And that gives me 4.1 and 11.3. All right, page 5. I'm going to skip number 4. We've already done a ton like that. I'm going to add in another problem. I'm going to say if vector u is the component form of 1, 2, v is negative 3, 4, and w is negative 5, 6, I want to find the component form for, let's do u plus v, w minus v, and let's do u plus v plus w. Okay, so we're gonna pause here, make sure you can write that down, and then I will explain how to do it. Okay, so when we are given the component form to add or subtract vectors, we can just add and subtract the components. Tomorrow, when we do this graphically, we'll graph them and do it graphically. So u plus v is I take the x components of u and v and add them. So 1 plus negative 3. And then I take the y components and add them. So 2 plus 4 is 6. I'm done. Now I could find the direction of this vector. I could find the direction of that vector. It doesn't ask that. It just says component form. There we go. So now w minus v, we're going to take the x component of w and subtract the x component of v. So that's negative 5 minus negative 3. So negative 2, and then 6 minus 4, 2. And then we can get wild and crazy and do 3 vectors added together. And that's going to take all the x components and add them. So 1 plus -3 plus -5. And then the y component, 2 plus 4 plus 6. So let's see, it's -8 plus 1 is -7. 6 plus 6 is 12. Okay, so your homework is page 6, numbers 1 through 4. So here are your 4 homework problems. Don't forget to check your answers in Drive.